integrals. It's not there on syllabus for them. But then suppose they want to learn sometime later on, whatever it is, so इसलिए मैं वो save करके रख रहा हूँ. Okay, so there's no problem with it. Nothing affects you. It's just that I'm recording it, and it's always a good habit to tell people that I'm recording. Correct? You shouldn't record in secret. Now that's other. Correct. So like this. Now we finished which exercise? 20 point. Which one we finished?
We have to check the number. No, we didn't send me that number, that last time exercise.
I sent na. नहीं भेजा?
We said a new one. नहीं भेजा. But we had questions left उसमें, so you said कि अभी hard वाले notes we'll do.
20.2 किया ना हमने. Which was the last problem we did?
We did question 30 marks.
30?
30.
I can't hear. 30.
The last one sent me.
Your voice is cracking up. Your voice is cracking up.
Okay, one second.
I want to check something over here. I forgot. Wait.
Is it okay now?
It's okay. Just 1 minute.
Hello?
1 minute. 1 minute. 1 minute. One minute.
Hello?
Yeah. 1 minute. I'm just checking whether the speaker works with them. I mean, there's a headphone. Okay. I just want to check. 1 minute. Huh?
Yeah.
Okay. Can you hear me?
Yeah.
Okay. Then wait. Then this is both the things. Now can you hear me?
Yeah.
Okay. Can you speak something? Question 31. Okay, we did that. Fine. ठीक है. So the 32 I think you can do on your own. That's all fine. We'll do 33rd problem. Okay, and that is I is equal to integral 0 to 1 minus x square upon x raised to 4 plus x square plus 1 dx. So what to do? Divide by x square. Correct. So this will be equal to integral 0 to 1, and it will be 1 upon x square minus 1, and this will become x square plus 1 by x square. Okay, so what we'll have to do is take minus sign out common. Correct. So this will be minus integral 0 to 1, and this will become 1 minus 1 by x square, and this we will have to write x plus 1 upon x the whole square. So that makes it plus 2. We have plus 1, so we have to subtract minus 1. Correct? So now put x plus 1 upon x as t. So 1 minus 1 upon x square dx is equal to dt. Okay. Now what will happen is when x is equal to 0, this is a problem now. ये 0 है ना, so x cannot be 0. So when x is equal to 0, t is going to be infinity. Correct? Because it will be 0 plus infinity, so it's going to be infinity. Okay, and when x is equal to 1, t will be equal to 2. right? So therefore I will be equal to integral infinity to 2, and this is 1 minus 1 upon x square dx is dt, and this part will be t square minus 1 square, which is equal to, so this is a square minus x square, so it's 1 upon 2a into log of a plus x, so it's t plus 1 upon a minus 1, t minus 1, limits what, it's a square minus x square na, a plus x upon a minus x. Oh, I wrote, sorry, I wrote t plus 1, oh sorry, okay, okay, it's 1 plus t and 1 minus t, okay, and this is infinity to 2, so this is correct now, so that's 1 by 2 into log of 1 plus 2 upon 1 minus 2 minus log of, this is 1 plus infinity upon 1 minus infinity, okay, and so this is equal to half into log of 1 plus 2, so it's log mod 3 upon minus 1, and now what to do with this one, log of mod infinity upon infinity basically, correct now, so that essentially is 0 actually, so that's half into log of mod 3, okay, which is equal to half log 3. So we'll check this answer. This is 33rd question. Half log 3. Okay? Fine. That's fine. I'll later on check if there is another method to do this, but at present, okay. Fine. Then 34th you can try on your own. 35th also you can try. We'll go with 37th. It came in CBSE 2004. So I is equal to integral 0 to 1 root of 1 minus x upon 1 plus x dx. So how to solve this? Yeah, we'll multiply by root 1 minus x. We can think of one idea. We can think, what if we substitute x is equal to cos theta? Because it's definite integrals, that's why, not otherwise. Okay, not otherwise, only because it's definite integrals, we can think of an idea. X is equal to cos theta. So what will happen to that root sign? It will be 1 minus cos theta upon 1 plus cos theta. That is 2 sine square theta by 2, 2 cos square theta by 2. So that will come out as tan theta by 2. Okay, and dx will be minus sine theta. Dx will be minus sine theta because x is cos theta. So it's minus sine theta. Minus sine theta is minus 2 sine theta by 2 cos theta by 2 d theta. Correct? And then tan theta by 2 can be written as sine theta by 2 upon cos theta by 2. So this will cancel and you will basically get my, yeah. What? No, root of tan square theta by 2 hai na? It is root tan square theta by 2. Huh? So root tan square theta by 2 hai na ye. So it's sine theta by 2 by cos theta by 2. Okay, so that's why we are cancelling it. So minus 2 sine square theta by 2 aa jayega ye, which we can integrate, but we have to check the limits now. When x is 0, theta will be cos inverse 0, which is 0. Correct? Right? And when x is 1, then theta will be theta will be pi by 2. I'm so sorry. Theta will be pi by 2, and when x is equal to 1, cos theta is 1, so theta is cos inverse 1, which is 0. So you can get the limits and you are dealing with this problem. So you can solve it like that also. Okay? That will be much easier, na? Correct? Okay. Okay. Anyways, I just wanted to check with this keyboard headphone. मेरा काम हो गया है. So I'm removing this. I'll be on normal speaker. So you can hear me, right?
Yeah.
Yeah. Okay.
Huh.
So with this one, uh, so you can do this problem both the ways. You can write this integral 0 to 1 and make it as 1 minus x upon root of 1 minus x square. Correct ना? You were saying ना multiply and divide by
Yes.
1 minus x. So उसमें ये ऐसा आ जाएगा. And then you can separate it. This will be 1 upon root 1 minus x square minus x upon root 1 minus x square. Integral 0 to 1, integral 0 to 1. So this one will give you the answer sine inverse x. 0 to 1.
Yes.
And this one you'll have to write it as half plus half minus 2x over here. So that becomes plus half integral 0 to 1 d by dx of 1 minus x square upon root of 1 minus x square dx. Okay, so this becomes sine inverse of 1 minus sine inverse of 0 plus half into this is d by f dash x upon root f of x, which is 2 root f of x.
Log of 1 minus x.
No, 2 root f of x.
Oh, yes. Right.
F dash x upon root of f of x is equal
Hmm.
to 2 root f of x. Okay, so ये आ जाएगा 2. I'm taking it outside and inside is root of 1 minus x square. The limits are 0 to 1. Right? So sine inverse 1 is pi by 2 and sine inverse 0 is 0. And this 2 and 2
Yes.
cancels, so it's plus. And now root of it will be 1 minus 1 square minus root of 1 minus 0 square, which is equal to pi by 2 plus this everything is going to be 0 minus root 1. And so that's going to be the answer is going to be pi by 2 minus 1. Okay? 37th. So let's check the answer. 37th, 36, pi by 2 minus 1. Okay, no questions. Then 39th. Okay, till that time I'll send you this. I forgot anyways last time. तो अभी भेज देता हूँ मैं. 1 minute. I think I was doing something with video recording that day. Not your class, but some other one. And तो उसके चक्कर में मैं भूल गया भेजने का. So these are the problems. And these are the answers also. With some hints also are there. Okay. And okay, 37th it seems they are solved already. 37th वो लोग ने already solve कर दिया था. So there was okay. Anyway, it doesn't matter. 37th हो गया. 39th problem. So 39th is integral 0 to pi by 2 sin x cos x upon cos square x plus cos x 3 cos x plus 2 dx. to do?
Hello.
Yeah, what to do?
Yeah, I couldn't hear you. So we take the PD, the numerator as PD into Q dash, QD dash.
No, it's not of that form. क्योंकि एक तो sin x cos x है.
That's okay.
देखो चार्ट में कुछ है क्या?
Yeah.
See any of the form.
Okay. Yeah. The
Yeah, tell.
D equals to we take no wait. Those are both square. 1 second. No, there's nothing.
There's nothing, obviously. There's nothing over there. So if there is nothing, that means you need to substitute something.
Okay. Yeah. Right. We cos as T, and then sin x dx will become dt.
Correct. Okay. So see, that's what gives you an idea कि इसको substitute करना है या नहीं.
Hmm.
तो उधर पे कुछ दिखाई नहीं दे रहा है उधर. Correct ना? That four things you
Hmm.
must have seen. So उसमें कुछ दिखाई नहीं दिया. So it's not in any of those
Yeah.
forms. That means you have to think on your own what to substitute. So it's
Hmm.
easy then. Put cos x as t.
Yeah.
Okay. Put cos x as t. Sin x dx will be minus dt. So I'll write it later on directly only. This one has gone. t ये भी चले गए सब कुछ सिर्फ लिमिट्स चेंज करना है. So when x is
Yeah.
equal to 0, t is equal to cos 0, which is equal to 1, and when x is equal to pi by 2, t is equal to cos pi by 2, which is 0. And so therefore I will be equal to integral. It is 1 to 0. Cos x is t, sin x dx is minus dt divided by t square plus 3t plus 2. Okay. So now there are two methods.
Hmm.
You can you'll first write few things. It's minus integral 1 to 0 t dt upon t square plus 3t plus 2, which we can write as integral 0 to 1 t upon t square plus 3t plus 2 dt. Okay, when you change the limits, the sign changes. When you invert the limits,
Okay.
करेक्ट नहीं, इधर ये वन इधर था, जीरो इधर था, अभी वो चेंज हो गया, जीरो इधर आ गया, वन इधर आ गया. सो दैट्स बेसिकली द रीजन. सो इंटीग्रल a to b is equal to minus integral b to a. Fine. We'll be seeing that theorem now. Now what to do? We can complete the squares and solve this, or we can also have this as factorized. So this is
Direct.
this we can factorize at t plus 2 into t plus 1. Okay, now see, just because you factorize does not mean that now you have to write all these things. ये कि ऐसा t upon t plus 2 into t plus 3 is equal to a upon, ये सब लिखना है, ऐसे कुछ जरूरी नहीं है, ऐसे कोई कंपल्शन नहीं है. ओके, हम लोग क्या कर सकते हैं, वी कैन हैव एन आइडिया कि t रहना चाहिए, so that means there should be 2t somewhere and you want to subtract things. Okay, तो या हम लोग ये रफ में भी कैलकुलेट कर सकते हैं, या ऐसा है तो a का वैल्यू कितना होना चाहिए. You put t is equal to minus 2, it becomes minus 2 upon minus 2 plus 3. Correct? ये t plus 1, this is 1. Correct? So it will be a, how much we should get? What should I write? A will be how much? T is equal to minus 2 upon minus 2 plus 1. So 2.
Hmm.
A should be 2. That is sufficient information
Right.
को रफ में. in rough, that is a sufficient information, because now I'm going to write this as integral 0 to 1, and I'm going to write this as 2 into t plus 3 or t plus 1, okay, minus t plus 2 divided by t plus 2 into t plus 1. Did you understand what I did? मुझे a का
Yeah.
वैल्यू मिल गया था ना, ए का मिल गया मुझे 2, दैट इज अ सफिशिएंट इंफॉर्मेशन. तो मैं जब ये मल्टीप्लाई करता हूँ क्या हो जाएगा, a इंटू टी प्लस 1 ना.
Yeah.
So I know I'm going to get 2 into t plus 1, and b has to come now minus 1. You can check it. Okay, because ये finally इधर आंसर t आना चाहिए. तो अगर इधर 2t हो रहा है तो there should be only 1t subtracting, and that too that is coming from this t plus 2. So just subtract it. So 2t minus t, and it's balancing out. 2 minus 2 cancel हो रहा है. So why to write everything? तो ये थोड़ा डायरेक्ट भी कर सकते हैं. So this becomes equal to integral 0 to 1 2 into t plus 1 upon t plus 2 into t plus 1, okay, minus t plus 2 upon t plus 2 into t plus 1 dt,
1.
and this bracket also is there, so that this becomes equal to, now it's easy to solve. This will become equal to integral 0 to 1. This t plus 1 has cancelled, and so this will be 2 log. I'll take the integrals directly. This is equal to 2 log mod t plus 2
Yeah.
minus this t plus 2 is cancelled. It's log mod t plus 1, and the intervals are 0 to 1. Okay?
Yes.
Which is equal to 2 log mod 3 minus log mod 2. Okay, that is putting t is equal to 1 minus t is equal to 0.
Yes.
So that's 2 log 2 minus log 1. Okay. So 2 log 3 minus log 2, and so that becomes basically ये कितना हो जाता है, 2 log 3 minus 3 log 3.
Yes.
3 log 2, and log 1 is 0. Okay, plus 0, right?
Yes.
So this becomes log 3 square minus log 2 cube, which is equal to log 9 minus log 8, which is equal to log 9 by 8. ठीक है. So ये कौन सा प्रॉब्लम था, 39th.
39.
So 39th का आंसर log 9 by 8.
Yes.
Then 40th. I'm just not solving it, just asking you the questions. It's 0 to a, and this is x into root of a square minus x square upon a square plus x square dx. So what can we do in this case?
We can multiply by root of a square minus x square.
No, that will become difficult. और नीचे क्या आ जाएगा, a raised to, okay, we'll see what happens. Okay, ये जब भी तुम्हें ऐसे सोचते ना करना है तो ये मेंटली कैलकुलेट करना है, या एटलीस्ट रफ में, कि इधर आ क्या जाएगा, x इंटू ए स्क्वायर माइनस एक्स स्क्वायर, ये टर्म आ जाएगा, and in the denominator you will get root of a raised to 4 minus x raised to 4. Okay, and then do what?
Yeah.
इसके बाद क्या करना है? So there's no way out.
Yeah.
Correct? We can't separate anything. There's nothing to separate. You can, but वो कैसे हो जाएगा? You'll get x a square upon root of a raised to 4 minus x raised to 4 minus x cube upon root of a raised to 4 minus x raised to 4. तो फिर to solve this, you will have to put x square is equal to something.
Yeah.
Correct? A square तो constant है, वो तो बाहर आ जाएगा. You'll have to put x square as something, and to
And
solve this part you will have to put x raised to 4 as something.
yes.
So दो अलग अलग इसमें सॉल्व करना पड़ेगा. That's the alternative for it. Because once you put is x square as something, but उसमें भी problem है. नहीं, that's fine. That will cover up x dx will be covered up over there. ये
Yeah.
प्रॉब्लम ट्रांसफॉर्म हो जाएगा लाइक डी टी अपॉन रूट ए स्क्वायर माइनस टी स्क्वायर फॉर्म में आ जाएगा दिस वन. And this one will change to, this is actually the derivative only. इसको सिर्फ 4 ऐड किया इधर 1/4, तो ये dy dx of root a raised to 4 minus x raised to 4 है. So it will be 2 root a raised to 4 minus x raised to 4. Okay, ये इसका आंसर वैसे आ जाएगा. So that's one method and it's okay, we can do that, that's fine. Okay, so you try this at home. ठीक है, और कोई मेथड है क्या? Just as a check, nothing of sort. What if we again think of putting x square as a square cos theta, something like that? If we put x square as a square cos theta,
Yeah.
cos
Then
theta, cos 2 theta would be better option. I'll take it cos 2 theta. Okay, so when we substitute, of course we won't write x square is equal to this, we will write x is equal to a root cos 2 theta.
yeah.
That will say, but anyways this will be x square. तो इसका डेरिवेटिव क्या हो जाएगा? 2x dx will be equal to a square into minus 2 sin 2 theta d theta. ये इसका डेरिवेटिव हो जाएगा. तो o x, so if you take this 2, this will cancel off and you'll have x dx. So that is handled. Okay, x dx has been handled. It is minus sin 2 theta d theta. So that's no problem over there. ठीक है, minus sin 2 theta d theta, वो a square and all is there, that's true. So into a square किधर तो बीच में है, a square into this. ठीक है, ये x dx हो जाएगा. And from here what you will get? 1 minus cos 2 theta upon 1 plus cos 2 theta.
Yeah.
Okay, that is 2 sin square theta upon 2 cos square theta. That's root of tan square theta. That is basically tan theta.
Yeah.
So you get tan theta, and tan theta can be written as sin theta upon cos theta, and this one is into a square into 2 sin theta cos theta d theta with a minus sign over here. ठीक है, so ये cos theta cancel हो जाएगा, and then you'll get minus 2a square sin square theta d theta, and then the limits. So limits shouldn't be a problem. तो ये sin square को फिर you'll have to write 1 minus cos 2 theta upon 2 and solve it. So that's a pretty long method then.
Yeah.
We can solve, and my suggestion is solve also, but at home you can solve by both the methods. Okay,
Yeah.
सॉल्व कर लेना, बिकॉज एक कुछ भी चीज है ना, थोड़ा एक्स्ट्रा प्रैक्टिस किया तो अच्छा रहता है. ठीक है, सो बट द मेन वे यू वुड सॉल्व इज दिस मेथड. दिस इज अ बेटर ऑप्शन. बट जब भी बोलोगे ना तो थोड़ा सा सोच लेना कि क्या होने वाला है. ओके, राइट, सो यू डू इट एट होम नाउ. ठीक है, so I'm skipping over 41st, you can do that. 42nd also I'll skip through. That's easy, put cos 2 theta as t. 44th also you can do on your own. We'll go to 45th problem because we want to get into the theorems very fast. I is equal to 1 to 2 1 upon x into 1 plus log x the whole square. CBSE 2003.
Yeah.
Okay, what to do?
So 1 plus log x t.
Yeah, 1 plus log x is t. Only log x is equal to t. Both would be okay. So we'll put 1 plus log x is equal to t. So you'll get 1 upon x dx is dt. And so 1 upon x dx is dt. right? And so therefore I is equal to integral 1 to 2, and this will be dt upon I didn't change the limits. That's very simple. We didn't change the limits, so we have to change the limits first. Okay, ये गलती कभी मत करना. So when x
Hmm.
is equal to 1,
T is 1.
t is equal to 1 plus log 1, which is equal to 1 plus 0, which is 1. I'm recording now, so I have to write many things. So x is equal to 2.
Hmm.
So t is equal to 1 plus log 2.
Log.
Did we do this problem? No, no.
I think so.
ऐसा लग रहा है किया कर.
Huh.
Maybe something similar was there somewhere.
Yeah, yeah, something similar.
वो 1 plus log 2 की वजह से लग रहा है. Anyways, doesn't matter. So
Huh.
I will be equal to integral 1 के जगह पे 1 ही है,
Yes.
and 2 के जगह पे 1 plus log 2 है,
Huh.
and 1 upon x dx is dt, and 1 plus log x is t, so it's t square, which is equal to minus 1 by t.
Hmm.
1 plus log 2, right? So which is equal to minus 1 upon 1 plus log 2 minus of 1 upon 1, which is equal to minus 1 upon 1 plus log 2 plus 1, which is equal to minus 1 plus 1 plus log 2 upon log 2, 1 plus log 2. So minus 1 plus 1 cancels, and this is log 2 upon 1 plus log 2. Okay?
Hmm.
This is 45th question. Is the answer right? Log 2 upon 1 plus log 2. That's perfect.
Yeah.
Then cos raised to 5x. 46th problem.
Hmm.
So 46th problem. I is equal to integral 0 to अरे चले गया. I is equal to integral 0 to pi by 2 cos raised to 5x dx.
Hmm.
What do you do? You'll have to refer to the chart, perhaps.
Okay.
See if it's given. I think I gave. Maybe I missed out. Maybe I missed out. Anyways, it's easy. It's not. बाद में लिख लेना. See, if it
Huh.
was cos raised to 4x, then we have no problem. Correct? We know what to
Hmm.
do. If it's cos
Yes.
raised to 4x, the problem is now this is an odd power cos. If it was cos cube also, not a major
Hmm.
problem. We could have used 1 plus cos 2x, sorry, 3 by 4 into 3 cos x plus cos 3x. But it is cos raised to 5x. So what we can think of is we can write this probably like this 0 to pi by 2, and this is cos raised to 4x
Hmm.
into cos x dx, which can be written as integral 0 to pi by 2, and this is 1 minus sine square x the whole square into cos x dx.
Yeah. So now sin x can be t.
Now sin x can be t. This can be done for cos cube x also. Okay, cos cube
Hmm.
x का एक ही मेथड नहीं है 3 by 4 into that part. We can write this as 1 minus sine square x into cos x dx. Actually, this is faster method.
Hmm.
Okay, this is technically fine because you get
Yeah.
cos x minus sine square x cos x,
Hmm.
and then put sin x is t. Yeah, just put 1 minus t square, and then your job is done actually.
Yeah.
Okay, so इसमें अभी we'll put sin x is equal to t.
Hmm.
So therefore cos x dx is equal to dt,
dt.
and when x is equal to 0, t is equal to sine 0, which is equal to 0.
Hmm.
And when x is equal to pi by 2, t is equal to sine pi by 2, which is 1. And therefore I is equal to integral 0 to 1
Yeah.
minus t square square dt. Right?
Hmm.
That this becomes integral 0 to 1 minus 1 plus t square minus t raised to 4 minus 2t square.
Hmm.
And I integrate it. That's easy now. There's nothing much to do in this case. So
Yeah.
this is t plus t raised to 5 upon 5 minus 2 into t cube by 3, and the intervals are 0 to 1.
Hmm.
So that's going to be 1 plus 1 by 5 minus 2 by 3 minus 0 everything.
Hmm.
So that becomes 5 plus 1, 6 by 5 minus 2 by 3, and so that's 18 minus 10, so that's 8 by 15.
Hmm.
Okay, so that's 45th one. नहीं ये कौन सा है 46th one. 8 by
46.
15. 8 by 15. Okay.
Yeah.
Okay, so the remaining problems over there you can do on your own.
Huh.
So okay. Now next one is we see some properties of definite integrals, of course without proof.
Hmm.
Properties of definite integrals. What's happening in your college? What are they teaching?
They're teaching this only.
Definite.
Yeah, we just reached properties.
Okay, so they've gone much fast, that means
Yeah, very fast.
they didn't teach in between का सब कुछ
Hmm.
बीच का कुछ सिखाया नहीं.
हाँ मतलब बहुत रश करके सिखाया.
Okay, ठीक है, anyway, no problem. Okay, so the first property is integral a to b f of x dx. We have been using this property is
Hmm.
equal to integral a to b f of t dt. Okay, so
Hmm.
it's basically integration is not affected by the change in variable. Okay,
Yeah.
it doesn't affect it. It's remains going to remain the same. तो वेरिएबल से कनेक्टेड नहीं है वो. ठीक है.
Hmm.
This is not of major use to you. The primary
Hmm.
reason is because you're not going to prove anything.
Yeah.
Correct. You're not going to prove anything. When we are proving the theorems ना, तो ये result
हाँ.
important हो जाता है. ये result use
Okay.
हो जाता है. For you there is no need of this, so it's okay. Okay,
हाँ.
second one, integral a to b, this we have already told you many times. Integral f a to b f of x dx is equal to minus integral b to a f of x dx. ये हमने अभी यूज भी किया दो तीन.
हाँ.
Correct. Then the third one is integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where a is less than c is less than b. That means you are having this graph of a function, for example, and this is point a, this is
Hmm.
point c, and this is point b. So to integrate from a to b, you can integrate from a to c,
Then.
okay, and then from c to b.
Yeah.
Right. Okay, that's what it means. Fourth one. Fourth property is which one to use? Integral a to b, uh, a to b f of x dx is equal to integral a to b f of a plus b minus x dx. ठीक है, ये हमको यूज होने वाला है. We require this quite often. ठीक है, this is one we will require quite many times.
Okay.
देन इसका करोलरी है, इसका एक करोलरी है, एंड दैट इज इंटीग्रल 0 to a f of x dx. So now what has happened is your a has become 0 and your b has become a
Yes.
in the previous one. So it will be integral 0 to a. And now if you use this, what was this, f of a plus b? So that's 0
Hmm.
plus a. So that is f of a minus x. So
Hmm.
it's the previous one only. Fifth one is actually the fourth one only, but उसमें
Hmm.
वो zero आ गया नीचे. That's all. Okay.
Yeah.
So that's one theorem, and this we are going to use extensively. ये दो बहुत ज़्यादा use होता है. Okay.
Hmm.
Now the उसके बाद we require which one? हाँ, ये है sixth one, integral a to, no, not a to b, it's 0 to 2a, 0 to 2a f of x dx is equal to integral 0 to 2a f of 2a minus x dx. This is also used but not that much, but use करते हैं हम लोग, प्रॉब्लम्स आते हैं जिसमें ये यूज हो जाएगा.
Okay.
Okay. And then there is seventh one, uh, and the seventh one is to deal with the even and odd functions. Okay,
Hmm.
but before that, we also have one more theorem. I think I wrote something wrong over here. 0 to 2a f of x dx is 0. ये तो already था हमारे पास, but okay, this one can also be written like this: 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. So we can use it like this also. तो ये जरा दो थ्योरम्स थोड़े से क्लैश होते हैं, ठीक है.
Hmm.
Seventh one, then eighth one, and that is going to be of that even and odd functions. Okay, so ये even and odd functions का theorem तुमको लिखना है. 1 minute.
Yeah.
Statement मैं ढूंढ रहा हूँ. I don't want to write my own statement. Okay, and that statement I can find. Anyways, integral minus a to plus a f of x dx is equal to 0 if f of x is odd function. Okay, and is equal to 2 into integral 0 to a f of x dx if f of x is even function. So when we come across that values, we will see what is that even function and odd function. At present सिर्फ लिख लेना, ठीक है.
Yeah.
So if f of x is an odd function, and this is 2 into integral 0 to a if f is an odd function, even function. So now what happens is most of the times when problems actually come ना, हम लोग ने इतना सब प्रॉब्लम सॉल्व किए ना, बट जब
Hmm.
प्रॉब्लम्स आते हैं ना definite integrals के, listen to the key that I am telling you. When the problems on definite integrals come, usually check for these theorems first, then see कि अगर ये theorem के हिसाब से अगर problem solve नहीं कर सकते हैं, तो then what
Hmm.
we have done till now.
Yeah.
Okay, so in small words, if I want to say is definite integral problems come first, check these theorems, not the chart.
Yeah.
जो हमने जो चार्ट बनाया है, इतना लिस्ट बनाया है, वो नहीं
Huh.
देखना है कि इसको क्या सब्स्टिट्यूट करूँ, क्या ये करूँ, क्या. नो, यू गो विद दिस फॉर फर्स्ट फॉर द theorems that we have seen, this 6 7 theorems that has been done, उसको चेक
Yeah.
करना, ठीक है. So let's find the problem. Now this is one question I'll take. So it's integral minus 1 to plus 1 f of x dx. Okay, you have to find that where f of x is equal to 1 minus 2x when x is less than or equal to 0, and 1 plus 2x when x is greater than or equal to 0. दोनों जगह इक्वल टू क्यों दिया है लोगों ने, गलत किया है. ठीक है, नो
Yeah.
प्रॉब्लम. Okay, so we have to find this. Now we will actually follow for theorems. But what we recognize is this function has different definitions under different intervals.
Hmm.
करेक्ट. सो देयरफॉर इसके इंटरवल्स में क्या है, एक जीरो के नीचे अलग डेफिनेशन है, जीरो के ऊपर अलग डेफिनेशन है. करेक्ट ना.
Huh.
सो दिस फंक्शन इज लाइक दिस. सपोज दिस फंक्शन इज लाइक दिस, then below 0 it has another definition. So ये ऐसा है कुछ तो 1 minus 2x something like that. Okay,
Huh.
once it crosses the value 0 it has another definition and say it is a something like this, ऐसे कुछ तो है. Okay,
Yeah.
what a line curve is. In this case, it's not a curve; it's a straight line. So this is 1 minus 2x is one line. तो ये actually इसका ग्राफ तुम देखने जाओगे तो ये ऐसे आएगा. इसका स्लोप -1 है, -2 है. Okay, because if you consider y is equal to minus 2x plus 1, then its slope is -2. So
Yeah.
before x approaches 0, from -1 to 0, the slope is negative. So this line is little bit like this.
Hmm.
Okay, it cuts the y-axis at 1.
Yeah.
Okay, ये इधर तक ऐसा है. ठीक है, this is how the graph is. And the moment it goes beyond 0, it is 1 plus 2x. So this graph is like this. तो ये 1 minus 2x है, ये 1 plus 2x है. So you're finding the integral from -1 to +1. So it's changing the definition at 0.
Yeah.
Correct now. So what we will do is we will find the integral from -1 to 0 and 0 to 1. So therefore
Huh.
integral -1 to 1 f of x dx is equal to integral -1 to 0 f of x dx plus integral 0 to 1 f of x dx.
Hmm.
Okay. Now when it's between -1 and 0, the definition is 1 minus 2x. So it's -1 to 0, 1 minus 2x
Yeah.
dx. And when it goes above 0, the definition is 1 plus 2x. Okay?
Hmm.
So this integral is x minus 2 into x square by 2. Intervals are -1 to 0 plus 1 plus 2 into x square by 2. Intervals are 0 to 1. No, it's yeah, -1 to 0 and 0 to 1. Correct. So this
So
is
it'll be x plus 2. And
what?
in the second one, it'll be x plus 2 x squared by 2.
Why x plus 2?
So
Maybe
1
x.
plus 2.
Okay, I didn't take the integral. Oh, sorry. X plus 2. So 2 and 2 cancel. So you put x is equal to 0, this becomes 0 minus 0 square minus of -1 minus of -1 square
Hmm.
plus 1 minus 1 square plus 0 minus 0 square.
Hmm.
Correct?
Yes.
Or is it 0 plus we do 1 minus 1 by 1 square? ये बराबर लिखा. No, it's not 1
1
minus now, it's plus.
1.
ये 1 plus 1 square है
Hmm.
and this is minus.
Yeah.
So आ गया ये. So ये तो 0 है, minus of -1 minus 1
Hmm.
plus 1 plus
Plus.
1 is 2 minus 0. So this will be minus of -2, which is 2, and plus 2, which will be 4.
Yes.
Okay. So where is the answer? First one, yeah, 4 it is. Okay. Let's take another one. Integral 0 to 1 mod of 5x minus 3. Okay. So now how to deal with this problem?
So will we have two values for plus and
Yeah,
minus?
we'll have two values. तो उसमें कैसे आएंगे? We will have the idea that basically mod of 5x minus 3 is अरे यार ठीक है. Mod of 5x minus 3 is equal to 5x minus 3 under what
Yeah.
condition? 5x minus 3 is greater than 0, that is x is greater than 3 by 5, greater than or equal to 3 by 5.
Yeah.
Correct? So that is when x is greater than or equal to 3 by 5, and it is equal to minus of 5x minus 3 when x is less than 3 by 5.
Hmm.
Correct? So that means this
Yeah.
3 by 5 is the intervening point. Correct?
Hmm.
So therefore, integral 0 to 1, we will say let f of x equal to mod 5x minus 3. So integral mod 5x minus 3 dx is equal to integral 0 to 1 f of x dx, which is equal to integral 0 to 3 by 5 f of x dx plus integral 3 by 5 to 1 uh, f of x dx. Either you can write like this, or अगर direct लिखना है तो you can write like this: 0 to 1 mod of 5x minus 3 dx is equal to integral 0 to 3 by 5 mod of 5x minus 3 dx plus integral 3 to 5 mod uh, integral 3 to 5 1 mod of 5x minus 3 dx, which is now equal to integral 0 to 3 by 5. So when it's 0 to 3 by 5, from 0 to 3 by 5, that is x is less than 3 by 5.
Yeah.
Okay. Whenever that happens, the definition is minus of 5x minus 3. That's basically 3 minus 5x. And from 3 by 5 to 1, 5 mod of 5x minus 3 is 5x minus 3.
Hmm.
That's all.
Answer.
So इसका आंसर कितना आता है? 13/10. Let me know when you finish.
Yeah.
I'm feeling a little sleepy, so I'm just walking.
I got 56 by 50. No, 1 second. 61 by 50.
No, it should come 13 by 10. So that means you
Okay,
should
one
be
second.
getting 65 by 10 you should be getting.
Hmm. 5. Okay, yeah, 5 is right. Yeah.
Are you?
Huh. 10. Huh.
Right? Okay. One more. These are all solved examples.
Hmm.
Okay. So I'm little bit focusing on solved examples because then जल्दी जल्दी सब patterns cover up हो जाते हैं.
Yeah.
Okay. The one more, and I can't skip the solved examples totally also
Huh.
because पूछते भी है वैसे. You have to find the next one. Integral 0 to pi 0 to pi mod cos x dx. So now mod
So, cos
cos x is equal to cos x. Under what condition?
that into 0. So,
If x is between 0 to pi by 2.
hmm.
Correct? Na?
Yeah.
Right?
Hmm.
Because in the first quadrant it is positive.
Yes.
So as long as it over here 0 to is less than or x is equal less than or equal to pi by 2. So it's cos x. It goes in the second quadrant, then it will become minus cos
Cos.
x. Okay. If pi by 2 is x is less than pi.
Hmm.
Correct?
Yes.
No problem. So
No
now
problem. Okay.
integrate. Now integrate. It's simple. So therefore I is equal to integral 0 to pi by 2 mod cos x dx plus integral pi by 2 to pi mod cos x dx, which is equal to integral 0 to pi by 2, and when it's between 0 to pi by 2 mod cos x is cos x dx plus integral pi by 2 to pi, and this is minus cos x dx.
Hmm.
So solve this now. This one's answer comes as 2.
Hmm.
Solve it.
Yeah.
ठीक है. So these kind of problems now are sufficient. I'll put few more before you. You can try it later at home. These are solid examples, so you can try it later on. I'll give you the answers also. So first one is integral minus 5 to 5 mod of x minus 2 dx. Then integral minus 1 to 1 e raised to mod x dx. Then integral 0 to 2 mod of x square plus 2x. We will do this one. Okay, ये करेंगे हम लोग. मैंने लिख
Yeah.
दिया अभी तो ठीक है. So we'll do that. And ये एक NCERT problem है, which is integral 1 to 4 mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3. And there is one more NCERT question, and that is integral 1 minus 1 to 2 mod of x cube minus x dx. ठीक है. So we'll do that this problem. पहले मैं इनका आंसर्स भी दे देता हूँ, इनको ढूंढना पड़ेगा. मॉड x माइनस टू का आंसर किधर है? 29 है.
Yeah.
ओके. देन मॉड e रेश टू मॉड x ना, उसका आंसर है 2e माइनस टू. ओके. सो विल डू दिस. इसका ये प्रॉब्लम करना चाहिए कि हम लोग इसका भी ठीक है. ये दो प्रॉब्लम कर लेंगे हम लोग. ओके. एंड देन द नेक्स्ट वन विल सी वेदर टू डू और नॉट. तो ये दो प्रॉब्लम कर लेंगे. सो I is equal to integral 0 to 2 and that is mod of x square plus 2x minus 3 dx. ओके. सो अभी हमको ये देखना है ये कभी ग्रेटर देन जीरो है एंड कभी लेस देन जीरो है.
Yeah.
Understanding? Because when it is greater than zero, mod will be as it is. Correct. And when it's less than zero, we will have it minus sign. Right. So x square plus 2x minus 3, x square plus 2x minus 3 can be factorized as x minus 3, sorry, x plus 3 into x minus 1. Okay. So now x plus x square plus 2x minus 3 is greater than 0 and किधर less than 0 है वो ढूंढना है हमको. Where is it less than 0? So when it is greater than 0, basically it means x plus 3 into x minus 1 should be greater than 0, and in this case it should mean x plus 3 into x minus 1 should be less than 0. So it eventually boils down to our method of intervals, where this will be minus 3 and this will be plus 1.
Yeah.
So
It
ये
dropped.
plus what happened?
Oh, left the meeting right now. You just joined.
Okay, automatic हो गया ना.
हाँ.
Okay, you can see this ना.
नहीं, अभी नहीं. Not one.
नोट नहीं दिख रहा है.
अभी नहीं.
हाँ. ओके. दैट इज व्हाट इज हैपनिंग. वो नोट चले जाता है फिर. टुडे दिस कनेक्शन हैज बीन वेरी बैड. अभी थोड़ा अच्छा है. आ गया. ओके. सो वी गॉट दिस ना. ये 1 माइनस हमारा जो मेथड था, करेक्ट ना, प्लस माइनस प्लस. So
Yeah.
whenever x belongs to the interval minus infinity to minus 3 union with 1 to infinity, okay, whenever that happens, you have x, this the term x square plus 2x minus 3 greater than 0. Okay. And whenever you have the limits x belongs to minus 3 to plus 1, then x square plus 2x minus 3 is less than 0. You may say ये closed intervals किया तो if you use this as closed intervals, then this will be greater than or equal to 0. Similarly, this is closed intervals, so then this is less than or equal to 0. Right? अभी हमको जो लिमिट्स दिया है वो कौन सा दिया है? 0 to 2. 0 to 2. वो किधर आता है? इधर 0 है. Okay, somewhere over here is 0. From there till 2.
Yes.
So our breaking point is who? 1.
1.
Understanding? So we will take the integral from 0 to 1 and then 1 to 2. Follow the logic?
Yeah. For.
Okay. So हमारा भी इंटीग्रल आ जाएगा. Therefore this is got hanged up. Okay. So therefore integral 0 to 2, it is mod of x square plus 2x minus 3. Mod of x square plus 2x minus 3 dx is equal to integral 0 to 1 x square plus 2x minus 3 mod dx plus integral 1 to 2 mod of x square plus 2x minus 3 dx which
Hmm.
is equal to, अभी ये mod का क्या होने वाला है? Oh god, now it went. तभी से जा ही नहीं रहा था. Now it went.
Yeah.
Wait. Sad this is. कितने नीचे गए? You can start solving ahead, no problem.
Acha.
So ये क्या हो जाएगा? Integral 0 to 1. And what happens from 0 to 1? Is it positive or negative?
It is negative.
Negative. So this will be minus of x square plus 2x minus 3 dx plus integral 1 to 2 में positive है. So it's
Hmm.
x square plus 2x minus 3.
Yeah.
ठीक है?
Hmm.
So no, so that's easy. Okay, some people just don't understand this part. इसलिए problem हो जाता है. But now it should be easy now. Fine.
Yeah.
तो इसका इंटीग्रल्स है. ये तो माइनस साइन बाहर रख लो पहले के लिए.
Hmm.
And you have x cube upon 3 plus 2 into
Two.
x square by 2, so that's x square
Hmm.
minus 3x, and the intervals are 0 to 1,
Yes.
right?
Huh.
That completes the first person. Then you have the second one, and that same in values it's going to have x
Hmm.
cube upon 3 plus x square minus 3x, and the intervals are 1 to 2.
Yes.
So this becomes equal to minus, when you put x is equal to 1, this becomes 1 cube upon 3 plus 1 square minus 3 into 1. And the next part I'm not writing, it's 0 basically.
Yes.
Plus, this will become 2 cube, which is 8 upon 3 plus 2 square, which is 4 minus
Minus 12.
6,
No, 6.
6 minus, this is 1 by 3, and you have 1 square minus 3, right?
Hmm.
So what we do recognize is this term and this term will eventually cancel.
Yes.
Okay, and then this part is that 0, so only this much we have to do. This part
Hmm.
is 8 by 3 minus 2. So that's 8 minus 6 upon 3. So that's 2 by 3.
Hmm.
इसका आंसर आया है 4. That means that's not coming z. This, I think it doesn't cancel, I think so. कुछ तो गड़बड़ हो गया.
It will add because there's a minus there.
No, I was thinking a minus 1 here. This minus sign was for this one and plus sign is for this one.
No, there's a minus at the right at the beginning, and there's a minus over here in front of this.
Okay, so somewhere the minus sign just went off. The answer is coming, it should come like this, 5 by 3 plus 2 by 3 and plus 5 by 3. That is, this value is coming plus. I don't know what has gone wrong. Maybe kuch question that you'll check it later on.
Yeah.
I don't know which sign went wrong where. कोई समझ नहीं आ रहा.
So when we cut those two out, we can't cut them.
Why?
because इधर माइनस है and एकदम
ये भी
starting में
माइनस है. Okay, this is minus and this is also minus. Okay.
yeah
ठीक है. That's why this comes as 5 by 3. Yeah, minus 5 by 3. Okay, this value comes minus 5 by 3.
okay
Correct, na?
hmm
It's 1 by 3 plus 1 minus 3. So that 1 minus 3 is minus 2. So it's 1 by 3 minus 2. So it comes as minus 5 by 3. And bahar ka minus makes it plus. So that is 5 by 3.
yeah
Similarly, ये माइनस है लेकिन इधर भी minus 5 by 3 आता है. So it becomes plus 5 by 3 like that. Plus 2 by
yeah
3. Yeah. Okay, so the answer happens to be 4.
hmm
Okay, ठीक है. So, so you will try the next problem over there वो जो था. Okay, do
yeah
that. Yeah. वो तीन मॉड थे ना, you will have to check the limits किधर क्या हो रहा है.
हाँ okay
Try it. If you don't get, we will solve.
yeah
ठीक है. Yeah. Now, you know what? Some of the problems जो solved में है, they are important. So I can just skip over everything. Even the last problem जो है, you will do on your own. This is integral mod of x square minus x. जो अभी किया ना वैसे ही करना है.
yeah
You have to see where it is greater than 0 and where it is not. ये factorize हो जाएगा ना. This will be
hmm
x into x minus 1. So the point limits are 0 and 1. तो इसमें ये 0 है 1 है. तो ये किधर पॉजिटिव है किधर नेगेटिव है वो चेक करना है. ठीक है.
हाँ
एंड देन अकॉर्डिंगली गो. फिर भी नहीं आया तो आई विल सॉल्व.
yeah
प्रॉब्लम. बट ये प्रॉब्लम करना पड़ेगा. दो सॉल्व वी हैव टू डू दिस. And that is integral 1 by e to e log of x to the base e mod. Okay, so mod of this dx. Now how to do this?
so we take it the same way right
Huh?
positive and negative we take that
लेना है तो कैसे आएगा? So log x to the base e, इसका mod is equal to log x to the base e under what conditions? If x is greater than 1 and less than e, then it's positive.
हाँ
Correct?
yes
As long as x lies between 1 to e, x is greater than 1 and less than e,
hmm
then this value will be positive.
yes
इसका लिमिट में, okay, under this limit, that
hmm
is इसका upper limit. Otherwise, this you can say as long as x is greater than 1
hmm
and to infinity. Actually देखोगे तो 1 to infinity हो जाएगा. It is always positive.
hmm
Okay, but हमारा limit e तक ही है ना.
hmm
We have, though it's 1 to infinity है, but हमारा limit maximum higher limit is e, so we
yes
cannot go beyond this. Okay, and it is
hmm
log x is minus log x in general when x is less than 1.
हाँ
Whenever it's less than 1, like you remember 0 point something and all. So
हाँ
whenever it's less than 1, then it is, that is still minus infinity रहता है वो.
हाँ
Minus infinity to 1, it's less than, it's a negative value. फिर वो bar 3 and all those values come.
hmm
Correct? So, but हमारा lower limit actually है 1 by e.
yeah
So it's 1 by e to this.
hmm
So this is equal to, therefore, integral. Now this is tough work a little bit. So this is 1 by e to e mod of log x is equal to integral 1 by e to 1 mod of log x plus integral 1 to e mod of log x dx here will be dx, which is equal to integral 1 by e to 1, and log of mod x in that case is minus log x
Yes.
dx, plus integral 1 to e, and mod of log x is log x.
Log.
Now how do we solve this? How do we solve this? Log x, so we'll have to integrate by parts.
Yes.
So integrate it. So this will be equal to minus into log x into 1. So it's log x into integral 1 dx.
Hmm.
Okay, 0 to 1 by. We'll just find integral log x dx first. Why to
Yeah.
do it separately? Correct? So integral log x dx कितना आता है? Log x into 1 dx minus integral, you will have d by dx of log x into integral 1 dx dx, which is equal to minus into log x into x minus integral 1 upon x into x dx, which is equal to minus log x into x minus x. Okay,
Hmm.
so the first part will be I is equal to integral 1 by e to 1 and minus sign out log x into x minus x dx plus integral 1 to e log x into x minus x dx, right?
Hmm.
So this will be minus integral 1 by e. Okay, नहीं integral ले लिया है. I'm so sorry, this is actually the integral that has been taken.
Yeah.
ये मैं गलती से लिखा. ये ये यही इंटीग्रल है. So there is no
Okay.
difference over here. तो ये 1 by e and 1 है. There is a minus sign out.
Yes.
Okay. And so now we have to just deal with this part. So now put log x is equal to 1. So this will be equal to minus of log 1 into 1 minus 1 minus log 1 by e into 1 by e minus 1 by e
Hmm.
plus this is what limits 1 to e.
Yes.
So that's log e into e minus e minus log 1 into 1 minus 1, which is
Hmm.
equal to minus of log 1 into 1 is 0,
Yes.
right? Minus 1 minus. Now log 1 upon e is minus 1,
Hmm. Okay.
correct? Now because it's log 1 minus log e, so that's 0 minus 1, so it's minus 1
Hmm.
into 1 by e minus 1 by e
Yeah.
plus log e is 1, so it's 1 into e minus e minus this is 0, log 1 is 0 minus 1, which is equal to minus of 0 minus 1 is minus 1, and this will become minus 1 by e minus 1 by e, which is minus 2 by e, so this becomes
Hmm.
plus 2 by e
Yes.
plus this is e minus e is 0, and 0 minus 0 minus 1, so that's plus 1.
Hmm.
So yeah, minus of minus 1 will become 1,
Huh.
minus 2 by e plus 1, which
So
is
minus
equal to 2 minus 2 by e.
e.
Yeah, that's correct. Okay. सो दिखने के लिए इजी प्रॉब्लम है, एक्चुअल इंटीग्रेशन बहुत कुछ नहीं है,
Yeah.
बट इट इज टफ ऑल्सो,
Hmm.
करेक्ट.
Huh.
ये एक प्रॉब्लम सेट हो गया थोड़ा. नाउ ये दिस ग्रेटेस्ट इंटीजर फंक्शंस के प्रॉब्लम है, तो ये थोड़ा बाद में कर लेता हूँ मैं. We will do this also little later. So अभी जरा प्रॉब्लम मुझे जो चाहिए. What's the time?
4:23.
4:23. Okay, we have 5-10 minutes. तो उसमें ये एक बहुत बड़ा काम हो जाएगा. इसके ना ये जो पहले प्रॉब्लम्स है ना, उसके कुछ प्रॉब्लम्स रह गए, but I won't do it
Hmm.
right now because they involve that greatest integer function, that x.
Yeah. Okay.
Okay, तो उसके जरा प्रॉब्लम है, थोड़ी इनवर्स ट्रिग्नोमेट्री के भी है, so we'll see it later on little bit. ठीक है.
Huh.
So now I is equal to integral 1 to 2 root x upon root of 3 minus x plus root x dx. Okay. Now see, when you get problems na, in general, when you get problems, सबसे पहला डेफिनेट इंटीग्रल्स का कितना भी आसान प्रॉब्लम लगो,
Huh.
always check whether these theorems are first in application. That is, f a to b is f of a plus b minus x, or integral
Hmm.
a to b f sorry 0 to a f is equal to f of a minus x. ये पहला चेक करो.
Hmm.
ठीक है. Whenever you get a to b and all, this is the first thing you check. Then you, if you're not getting this, then you can think of the first theorem or the last theorem or whatever it is. और फिर कोई थ्योरम नहीं दिख रहा है, तो उसका मतलब हमारा जो प्रीवियस एक्सरसाइज में जो प्रॉब्लम सॉल्व किए by
Huh.
substitution this and all, the problem will be solved like that. ठीक है.
Huh.
So now this one, see, we will use this f of a plus b minus x. Okay, तो इसमें
Hmm.
ना try and understand, this is your f of x. Okay,
Yeah.
this is f of x. Now you have to replace x. If you see what is happening over here, according to the rule, replace x with a plus b minus x.
Hmm.
Okay, so this is equal to integral 1 to 2 root of 1 plus 2 minus x. Okay, replace x with a plus b minus x.
Yeah.
ठीक है, divided by root of 3 minus x is 1 plus 2 minus x,
Hmm.
minus root of 1 plus 2 minus x dx. ठीक है. Is that fine?
Yes.
Yes. This is equal to integral 1 to 2 root of 3 minus x upon root of x plus root of 3 minus x dx. Right?
Hmm. Yeah.
So this equation जो दिया था हमको, this equation I'll call it as equation 1. This equation I'll call as 2.
Hmm.
Okay. 1 minute and let it go further. Okay. So what I'll do is now I'll add 1 and 2.
Hmm.
Adding 1 and 2. What I'll get? I plus I is equal to integral. And what was the problem? 1 to 2. 1 to 2 root x upon root of 3 minus x plus root x dx plus integral 1 to 2 root of 3 minus x upon root x plus root of 3 minus x dx,
Yeah.
right? Which is equal to integral 1 to 2 root x upon root 3 minus x plus root x dx, not dx, plus root of 3 minus x upon root x plus root of 3 minus x dx,
Hmm.
which is equal to integral 1 to 2 root x plus root of 3 minus x upon root of 3 minus x plus root x dx. So these two terms are same, so they cancel. And so this will be equal to integral 1 to 2 1 dx, which is equal to x 1 to 2, which is 2 minus 1, which is 1. Okay, so therefore
Yeah.
I is equal to 1. This implies I is equal to 1 upon 2.
Hmm.
Okay, again.
Yeah. Okay.
Then, okay. My next problem is second one. Integral 0 to pi by 2 sin x upon sin x plus cos x dx. So the first thing we will do is
Check the theorem.
check the theorem. Okay, इधर गलती लोगों का क्या होता है ना, I'll tell you what is the mistake people do. They see this sin x upon sin x plus cos x. Okay,
Hmm.
they write this sin x is equal to p into sin x plus cos x.
Hmm.
Okay, plus q into sin x, derivative of this part, so cos x minus sin x. Okay, ये करते हैं उसके बाद then they'll write this p plus q, जो कुछ आता है p
Hmm.
minus q, they'll find that, then that will be 1, and बहुत long procedure है. If you see this problem without this p and q part, which you probably can solve p and q से, but the method would be much easier if you write it like this. This is equal to I, this is equation 1, and so this is equal to integral 0 to pi by 2 sine of pi by 2 minus x divided by sine of pi by 2 minus x plus cos of pi by 2 minus x dx, which is equal to integral 0 to pi by 2. Reason for this is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx.
Hmm.
So this will become cos x
Yeah.
divided by cos x plus sin x dx. This is equation 2. Okay. And so now what I'll do is I'll say adding 1 and 2.
Hmm.
Adding 1 and 2. We get 2I is equal to, it will be equal to integral 0 to pi by 2 the first integral plus
Hmm.
integral 0 to pi by 2 the second integral,
Yeah.
because the same limits 0 to pi by 2 0 to pi by 2, so it will be 0 to pi by 2 the first integral plus the second integral dx.
Yeah.
Okay, and that happens to be actually sin x upon sin x plus cos x,
Hmm.
and this is cos x upon sin x
Yeah.
plus cos x, so that will be 1,
Hmm.
which is equal to x 0 to pi by 2.
Yeah.
Okay. So therefore 2I is equal to pi by 2, which implies I is equal to pi by 4. Done.
Yeah.
Okay.
Yes.
So that's all for today.
Huh.
So we've done two theorems. उसके और थोड़े एक दो प्रॉब्लम बाद में देख लेंगे and the other theorems. ठीक है?
Okay.
So we'll cover up that. Right?
Huh.
Okay. So see you on Tuesday.
Yes.
Ciao.